Good evening, lecturers and my fellow friends. Today, our program is Chemi Chat, an initiative by Paul leaders for chemistry to create an environment that is suitable for learning chemistry as friends. My name is Pierarasan Sandran and I am the moderator for today's event. Before we start our event, I would like to introduce you to the panel of speakers today, which are Azizatul Rabia, Shu Jodi, Gayatri, Balkis Awatif, Lu Chia-ying, Ong Yi-yun, and Wong Xuan-rui. Before we start today's event, I would like to go through a few information regarding today's event. We will have a lucky draw event after the program where lucky winners will be selected through the Wheel of Names and the winners will be contacted. Now, let us start with our event. Let's start with question number 1, defining nucleon number. So, the definition of nucleon number is nucleon number is the total number of protons and neutrons in the nucleus of an atom of an element. So, to score marks in this question, you have to include the key points, total number of protons and neutrons in the nucleus of an atom. For question D, give the number of protons, neutrons, and electrons in each of the following species. Let's look at species 1. This is species 1. Br or bromide refers to the element, minus here refers to the charge, 79 refers to the nucleon number, and 35 refers to the proton number. This is the isotopic notation. From this isotopic notation, we can conclude that the number of protons is 35, the number of neutrons is the nucleon number subtracted by the number of protons, which is 44, and the electrons is 36. This is because this is a negative 1 ion, which means that it gains 1 electron, therefore it has 36 electrons. Let's look at species 2. This is species 2. From this species, we are able to identify that it has 56 protons, 74 neutrons because 130 minus 56 is 74. However, it has 54 electrons only because this is a 2 plus ion, which means it has lost 2 electrons. Therefore, 56 minus 2, you will get 54 electrons. Before we move forward to question number 2, do you have any questions? Do leave it in the comment section. All right, let's proceed to question number 2. For question number 2, I would like to call upon Azizatul Rabia.
Hi everyone, my name is Aizatul Rabia from H3TO1B. So now we'll move on to the second question. The following figure shows the mass spectrum for copper Cu atom, which has been identified to have 2 isotopes. Okay, now we'll see the diagram. Okay, there's actually a few information that we can pick up from this diagram. Okay, contoh dalam soalan ni, kita tengok dia dah bagi dekat kita yang dia dah bagi kita 2 isotop kan. Okay, kalau kata soalan tak bagi, we can actually find how many isotopes involved in this question. We look at the number of peaks in this diagram. So we can see that the first is copper 63 is the first peak, and the copper 65 is the second peak, means there are 2 isotopes involved in this diagram, in this question. Okay, other than that, we can also find the abundance of isotopes by looking at the height of peaks. Okay, first we can see the copper 63 has a higher peaks than copper 65. Means copper 63 is having a higher abundance of isotopes than copper 65. Okay, then we move on to the second. Okay. So first question, define isotopes. So isotopes are 2 or more atoms of the same element which have the same number of protons but different numbers of neutrons in the nucleus. So this is how you're going to answer the definitions of isotope. Okay, next. Using the information given in the above figure, calculate the abundance of each isotope for copper. So first we find the average atomic mass is equal to 63.6 U. Okay, then because we want to calculate the abundance of each isotope, we assume that copper 63 is equal to X, while copper 65 is equal to 100 minus with X. Okay, then we use the formula of average atomic mass is equal to totals of Qi times Mi divided with totals of Qi, where Qi stands for relative abundance or percentage abundance of an isotopes of the element, depends on the question, while Mi is equal to the isotopic mass of the isotope of the element. Then we substitute the value inside of the formula. Okay, we get like this. Okay, then we rearrange the equation. We wanted to get X. So then we get X is equal to 66.46. Okay, then we substitute the value of X inside of our assumption equation that we just made, where copper 63 is equal to X, while copper 65 is equal to 100 minus with X. Then copper 63 is equal to 66.46, while copper 65 is equal to 100 minus with 66.46 equal to 33.54. That is how we find the abundance of each isotope for copper. Thank you.
All right, let's move on to the third question. Before that, do you have any questions? Please put it in the comment section. Okay, let's move on to question number 3. For this question, I would like to call upon Shu Jodi.
Okay, so question 3 is about empirical and molecular formula. An analysis of gaseous hydrocarbon compound gives the following percent composition by mass, which is 85.7% of carbon and 14.3% of hydrogen. First of all, we need to define empirical formula and molecular formula. Both empirical formula and molecular formula are chemical formula, but empirical formula is a chemical formula that shows the simplest whole number ratio of atom of elements in a molecule, which means that we can only use whole number as a ratio, but not any fraction or decimal. Molecular formula is a chemical formula that shows the actual number of atoms of each element in a molecule. Next, we are going to talk about the empirical formula of the hydrocarbon. In order to answer this kind of question, we need to assume that the mass of the sample is 100 grams. Next, we need to draw a table. In the first column, we are going to write about the element, which are carbon and hydrogen in this question. In the next row, we are going to write about the mass in unit of gram. Since you assume that the mass of the sample is 100 grams, then the mass of carbon will be 85.7 grams, while the mass of hydrogen will be 14.3 grams. In the third row, we are going to write about the number of moles. In order to calculate the number of moles, we will use the formula mass divided by molar mass. 85.7 grams divided by 12, we will get 7.14 mole. 14.3 grams of hydrogen divided by 1, we will get 14.3 mole. In the last row, we are going to find the mole ratio. In order to find the mole ratio, we will use the number of moles that we have obtained in the third row and divide it with the smallest number of moles. So 7.14 divided by 7.14, we will get 1, while 14.3 divided by 7.14, we will get 2. As a result, the empirical formula of the hydrocarbon will be CH2. And in question C, 0.25 gram of this compound occupies a volume of 100 ml at STP. Determine the molar mass and the molecular formula of the hydrocarbon. Since we know that 1 mole of compound will occupy 22.4 liter at STP, then by doing some calculation, we will find the number of mole of the hydrocarbon, which we use 0.1 divided by 22.4, we will get 0.004464 mole. Next, we are going to find the molar mass of the compound by using the formula molar mass equal to mass divided by number of moles. So molar mass of CH2 will be 0.25 gram divided by 0.004464 mole, which will get 56 gram per mole. Next, we are going to find the molecular formula. N times CH2 will get 56, and we substitute the mass, we'll know that N times 12 plus 2 times 1 equal to 56. Then we'll get N equal to 4. When we use 4 times CH2, we'll know that the molecular formula is actually C4H8. Thank you.
All right, thank you, Shujodi, for question 3. If you have any questions, do leave it in the comment section below. All right, let's move on to the fourth question. I would call upon Gayatri to explain the fourth question.
Hi everyone, my name is Gayatri from H2T3B. For question 4, a complete combustion of a hydrocarbon forms 1.10 gram of carbon dioxide and 0.45 gram of H2O. The molar mass is 84.00 gram per mole. Determine the empirical formula and molecular formula of the hydrocarbon. To solve this question, we have to find the mass of hydrogen and carbon. To find the mass of carbon, 12.0 plus 2 times 16.0 gram of carbon dioxide contains 12.0 gram of carbon. 1.10 gram of carbon dioxide contains 1.10 plus 12.0 times 12.0 divided by 12.0 plus 2 times 16.0 carbon, which you will get 0.3 gram of carbon. To find the mass of hydrogen, you take 2 times 1.0 plus 16.0 gram of H2O contains 2.0 gram of hydrogen. 0.445 gram of H2O contains 0.45 times 2.0 divided by 2 times 1.0 plus 16.0 H, which you will get the mass of hydrogen, which is 0.05 gram. In order to find the empirical formula, you have to draw the table and label it with elements C and H. Next, we have to fill in the mass of carbon, which is 0.3 gram, and the mass of hydrogen, which is 0.05 gram. Number of moles. 0.3 gram divided by 12.0 gram per mole, you will get 0.025 mole. 0.05 gram divided by 1.0 gram per mole, you will get 0.05 mole. Next, we have to find the mole ratio. 0.025 divided by 0.025 equals to 1, and 0.05 divided by 0.025 equals to 2. Thus, the empirical formula is CH2. To find the molecular formula, we have to take N times CH2, you will get 84.00. N times 12 plus 2 times 1 equals to 84.00. N equals to 6. So that when you substitute N into the CH2, the molecular formula will be C6H12.
Okay, thank you very much to Gayatri for question number 4. We have a question for the panelists. Molar mass of CH2 should be replaced by molar mass of CH2N. All right. Do any one of the panelists want to explain on the question? Okay, that it wasn't a question. That was actually an advice. So let's move on. So thank you for the advice. Let's move on to the next segment of our program, which is a short 5 minute break. So for the 5 minute break, you may refresh on the notes given, and you may also look through back from the questions that we have discussed, so that we can you can ask more questions later on. Okay, we shall have a 5 minute break now. Okay, that was a refreshing 5 minute break. Let's move on to question number 5. Before we do so, do you have any other questions? Okay, so let's move on to question number 5. To move on to question number 5, let me invite Balkis Awatif.
Hi, my name is Balkis Awatif. I'm from H3T04A. Okay, we move to question number 5. The question is 55 milliliter of a saturated sodium hydroxide solution with 60% sodium hydroxide by weight has a density of 1.80 gram per milliliter is diluted to produce a 0.20 molarity sodium hydroxide solution. Determine the initial concentration in molarity of the saturated sodium hydroxide and the volume of water needed in order to prepare the 0.2 molarity sodium hydroxide solution. Next. Okay, first, we use formula density of sodium hydroxide solution equals to mass of sodium hydroxide solution per volume of sodium hydroxide solution. Okay, why we use this formula? Because it much more easier to us to find the value of mass of sodium hydroxide solution because the density of sodium hydroxide and the volume has already given. So we just substitute the density is 1.80 equals to mass of sodium hydroxide solution, the value that we need to find, then per 55 milliliter. So the answer for mass of sodium hydroxide solution is 99 gram. Okay, next we're going to use a formula percentage of mass of sodium hydroxide equal to mass of sodium hydroxide solute per mass of sodium hydroxide solution multiplied by 100%. Okay, the percentage has already given in the question, so we just substitute 60% equals to mass of sodium hydroxide solute per 99 gram. Nilai 99 gram ni kita dah dapat daripada pengiraan kita yang cari tadi. So we just substitute juga. So we multiply 100% and then we calculate, and the answer for mass of sodium hydroxide solute is 59.4 gram. Next. Okay, next we're going to find number of mole of sodium hydroxide solute. So we're going to use number of mole of sodium hydroxide solute equals to mass of sodium hydroxide per molar mass of sodium hydroxide. Okay, mass of sodium hydroxide is 59.4 per 40 gram per mole. Okay, how we get this 40 gram? We just plus relative atomic mass for natrium is 23 and oxygen is 60 and hydrogen is 1, so we just plus, and then the total is 40 gram per mole. And then we divide, and the answer for number of mole of sodium hydroxide solute is 1.485 mole. Okey, lepas kita dah cari semua nilai, baru kita boleh jawab soalan. Soalan minta determine the initial concentration, and then baru kita guna formula molarity of sodium hydroxide solution initial equals to number of mole of sodium hydroxide solute per volume of sodium hydroxide solution. Okay, volume of sodium hydroxide must in liter. So kita kena convert 55 ml ni kepada liter. Okay, and then kita substitute nilai 1.485 per 55 exponent negative 3, and then we divide, and the answer for molarity of sodium hydroxide solution is 27 molarity. Next. Okay, next we're going to find the volume of water needed. So we use formula M1V1 equals to M2V2. Okay, and we substitute the molarity is 27 multiply volume is 55 equals to molarity is 0.2, and then kita nak cari V volume V2. So kita calculate, and then V2 kita dapat 7,425 ml, and then mililiter ni kita kena convert kepada liter, kita bahagi 1,000, and then kita dapat volume is 7.425 liter. Okay, the last step, okay, kita nak cari volume of water needed, we just minus 7.425 minus 0.055, and then the answer is 7.37 liter. That's all for question number 5.
Thank you very much to Balkis Awati for question number 5. Before we move on to question number 6, let's see if there is any questions. All right, let's move on to question number 6. So for question number 6, let me call upon Lu Chia-ying. Sorry, we are experiencing some technical problems. For now, we would move on to question
everyone,
7.
my name is Lu Xiaoying. I'm from H2 fraction of 2.0 dm cube. Use 1 dm cube will be easier in our calculation. Sometimes we will confuse that when we need to define the chemical equation for the following figure.
I'm sorry, we are experiencing some technical difficulties. Let's move on to question 7 with Ong Yi Yun.
Hello everyone, my name is Ong Yi Yun from Practicum H7T3B, and now I will proceed with the subtopic Stoichiometry. So question 7 goes like this. Nitric acid and HNO3 and nitrogen monoxide NO are produced from the reaction between nitrogen dioxide NO2 and water H2O. If 90 grams of HNO3 is produced from the reaction between 130 grams of NO2 and 95 grams of H2O, A. Write a balanced chemical equation for the formation of HNO3. So in order to write a chemical equation, we must first identify the reactants and the products. So the reactants can be identified from the question highlighted in blue, nitrogen dioxide and water, while the products are as highlighted in purple, nitric acid and nitrogen monoxide. So we first write them down in the form of a chemical equation, and then we have to remember to balance the number of elements on both sides of the equation and also add in their states. So our final chemical equation would be 3NO2 plus H2O forms 2HNO3 plus NO. So next, B, determine the limiting reactant in the reaction. So limiting reactant can be defined as the reactant that is completely used up in a chemical reaction and limits the amount of product formed. So in order to determine which reactant is the limiting, we usually calculate the number of moles for both reactants first. So we start by calculating number of moles of NO2, which is mass divided by molar mass equals 130 grams divided by 46.0 gram per mole, we get 2.826 mole. For number of moles of H2O, we take 95 grams divided by 18 gram per mole, which is the molar mass for water, and we will get 5.278 mole. So these are the number of moles for both reactants. And by referring to the chemical equation we balanced previously, we now compare the number of moles. So from balanced equation, 3 moles of NO2 will react with 1 mole of H2O. So 2.826 mole of NO2 will react with 0.942 mole of H2O. However, the number of moles of water given in the question is actually 5.278 mole, which is greater than 0.942. So we can conclude that water is actually present in excess. And when one of the reactants are present in excess, the other reactant will be the limiting. So limiting reactant is NO2, nitrogen dioxide. So next question C, determine the percentage yield of the reaction. In order to calculate percentage yield, we can use the formula below. Percentage yield equals to actual yield divided by theoretical yield times 100%. So actual yield is provided in the question, which is 90 grams. And now we have to calculate the theoretical yield and also find out the percentage yield. So by referring again to the balanced chemical equation, we now compare the number of moles by using NO2. The reason we use NO2 is because we have already determined that NO2 is the limiting reactant. And we always use the limiting reactant in order to find out the amount of products formed. So from balanced equation, 3 mole of NO2 will react with will produce 2 mole of HNO3. Hence, 2.826 mole of NO2 will react with will produce 1.884 mole of HNO3. So now we have the number of moles of product formed, and we have to calculate its mass. So mass of HNO3 produced equals to number of moles times molar mass, which is 1.884 mole times 63 gram per mole, and we get 118.7 gram. This 118.7 gram is actually the theoretical yield. However, our actual yield is only 90 grams. So by applying the formula, percentage yield equals to actual yield divided by theoretical yield times 100%, we take 90 divided by 118.7 times 100%. And our final answer of percentage yield will be 75.8%. So that is all from me. Thank you.
All right, let's move on to the 8th question. For that, I would like to call upon Wong Xuan Rui.
Hi everyone, my name is Wong Xuanrui and I'm from H63B. Let's proceed to question 8. Silicon tetrachloride may be used as an intermediate in the manufacture of high-purity silicon for the semiconductors industry. It can be prepared by heating silicon in excess of chlorine gas. The balanced chemical equation is given below. A. Calculate the mass of silicon required to produce 420 grams of silicon tetrachloride if the percentage yield is 45%. The actual yield of silicon tetrachloride given is 420 grams, while the percentage yield is 45%. So we have to calculate the theoretical yield by applying this formula. 45, which is the percentage yield, is equals to 420 grams, the actual yield, and is divided by the theoretical yield times 100%. Next, we arrange the equation and we can find out the theoretical yield, which is 933.3 grams. Next, we have to calculate the number of moles of silicon tetrachloride by using the formula mass divided by molar mass. The mass, which is 933.3 grams, divided by the molar mass of silicon tetrachloride, hence the number of moles is 5.487 mole. Next, we have to compare the ratio of the number of moles. From the balanced equation, we know that 1 mole of silicon tetrachloride is produced by 1 mole of silicon, so the ratio is 1 to 1. 5.487 mole of silicon tetrachloride is produced by 5.487 mole of silicon. Lastly, we can calculate the mass of silicon by multiplying the number of moles and the molar mass. The number of moles calculated is 5.487 moles, multiply the molar mass of silicon, which is 28.1. Hence, the mass of silicon required is 154.2 grams. Question B. Calculate the amount of unreacted chlorine in mole if 13.5 mole of chlorine is used. From the question, it is mentioned that chlorine is in excess. So firstly, you have to compare the ratio of the number of moles from the balanced equation. 1 mole of silicon tetrachloride is produced by 2 moles of chlorine. Hence, 5.487 moles of silicon tetrachloride is produced by 5.487 times 2 moles of chlorine, which the mole of chlorine reacted is 10.974 moles. Finally, calculate the number of moles of unreacted chlorine, which is 13.5 mole minus 10.974 moles. So the moles of unreacted chlorine is 2.526 mole. Thank you.
All right, now let's move on to question 6, which was delayed earlier. So for question 6, I would invite Lu Chia Ying.
Hi everyone, my name is Lu Xiaying. I'm from H2D3A. Sorry for the technical problem just now. So the sixth question asks, calculate the mole fraction of 2.05 molar ammonia in the water if the density of solution is 1.15 gram per cm cube. First, we need to assume that the volume of an ammonia solution is equal to 1 dm cube. Why we use the value of 1 dm cube as assumption but not other value? This is because the unit of molarity is 1 dm cube is mole per dm cube. So use 1 dm cube will be easier in our calculation. Sometimes we will confuse that when we need to do assumption. If given more than 2 data, then no need assumption. But if given only 2 data, then we need to do assumption. The second step is to convert the given data. The formula of molarity is equal to the number of mole of solute over the volume of a solution. So we substitute the value into the formula. 2.05 is equal to the number of mole of ammonia solute divided by 1. Number of mole of ammonia solute is equal to 2.05 mole. The second data given is the density of an ammonia solution. The formula of density is mass over volume. 1.15 is equal to mass of ammonia solution over 1000 cm cube. So the mass of ammonia solution is equal to 1150 grams. Then, use the data that found in the step 2 to find the data we want. We can find the mass of ammonia solute by using a number of mole times the molar mass of ammonia, which is 2.05 times 17. The answer will be 34.85 gram. To find the mass of solvent, minus the mass of ammonia solution with the mass of ammonia solute. Now we have the mass of solvent, which is 1115.15 gram. Here, we assume the solvent is water. So we use the mass of solvent over molar mass of water, which answer will be 61.95 mole. The last step will be find the final answer. Next. The formula of mole fraction is number of mole of solute over total number of mole. The number of mole of ammonia solute is 2.05 mole. The total number of mole is equal to number of mole of solute add with the number of mole of solvent, which is 61.95 plus 2.05. At the end, we will get the answer, which is 0.03203. We can also write it in the standard form. That's all for question 6. Thank you.
Thank you very much, Lu Chiaing, for explaining question number 6. Okay, so now it is time for the Cabutan Virtual, okay, where we are going to choose few lucky winners. So before we move on to the Cabutan Virtual, there will be a slight 1-minute break for some technical issues. Okay, so this is the wheel of names that we have typed in. I'm very sorry for any inconvenience caused. There was a slight technical issue. So let's see who is the first lucky winners. For your information, we will have 5 lucky winners. So, okay, let's see who is the first lucky winner. You can click. Okay, congratulations, Mogeshni anak perempuan Suresh. You are the first lucky winner. Let's look at the second lucky winner. Okay, Nurul Shahira binti Muhammad Tarmizi. Congratulations, you are the second lucky winner. Okay, now the third lucky winner. Okay, congratulations, Tan Yunju. The fourth one. Okay, congratulations, Char Gianni. Okay, let's look at the last lucky winner. Okay, congratulations, Lim Ruche. Okay, thank you very much. I think this comes to the end of our Chemi Chat program for today evening. Thank you very much for all the attendees. We hope that you have a nice night. Thank you very much for participating in this program.